In this video, we are going to take a look at equations for exponentials. We've looked so far at linears, and we did quadratics next, and then we moved on to exponentials. So we are going to look at equations for both linears and exponentials. To begin with, we're going to look at a linear situation. So here's our table, x, f of x. So for my x values, it's 0, 1, 2, and 3. And my f of x values are going to be 7, 9, 11, and 13. So I know this is a linear situation because when I look at what's going from one number to the next, on my x side and my f of x side, they're both counting by the same constant. So on the left-hand side, each time I'm adding 1. It doesn't have to be adding 1, but in this case I'm adding 1. On the right-hand side, I'm adding 2. Because there's the same constant that's going on between each of these sets of points, this is going to make it linear. There's that constant rate of change we call slope. So if we get something like this, where we're adding on the left side and adding on the right side, this is called the add-add property. And this is always linear. So the add-add property says adding a constant to the value of x adds it's a possible different constant, but it could also be the same constant, to f of x. So adding a constant to the value of x also adds a constant, some specific constant, to the f of x value. This is going to be a linear situation. And you guys can find linear equations. I mean, if you think about how do I find a linear? Y equals mx plus b. Or point slope form works as well. Y minus y1 equals m times the quantity x minus x1. So we're going to take a look at how do I write an equation for this situation. So I'm going to come up with another example that you can look at. Okay, why is this linear? And then what's the equation for it? So we'll leave that there. So here's our example for my table. Let's see, I've got 2, 3, 4, 7, 6, 11, and 10, 19. Okay, so this is my list of values. I should be able to figure out if it's linear, that it does follow that add-add property. So if I take a look at the left-hand side, here I'm adding 2, then I'm adding 2, and in this case here, I'm adding 4. So it's not quite add-add yet, because I'm not adding by the same constant. If I were adding by the same constant, I'd have to add a 2, which would make it 8, and add a 2 again, which would make it 10. So I'd have to squeeze in that little 8. So my f of x side, first I'm adding 4, and I'm adding 4, and then I'm adding 8. But again, same thing, can't add 8, I can only add 4. So if I add 4 here, that gives me 15. And if I add 4 again, that gives me 19. So that does actually work. So just taking a look at that there. Again, I was missing some of those values along the way. So I had to add in that extra point, 815, to make it an add-add process. I didn't really add any numbers to the table. This is just a list of numbers that makes up my function. So if this were add-add, I definitely have to add by the same constant. Okay, so now we're going to find an equation for this. Since it's add-add, we know it's linear. So this is going to be y equals mx plus b. So I have to find the m value and I have to find my b value to write my equation. M is the change in y over the change in x. Since I already have my table set up, I already know my change in y is 4 and my change in x is 2. So I automatically know right away from the beginning my slope is 2. Now, if I didn't know that, I'd have to use my slope formula. Remember, m equals y2 minus y1 over x2 minus x1. Okay, your slope formula. So now I have to find my b value one of two ways. Well, one of three ways, I guess I could do it. I could have started with point slope form and then just transferred it over. At this point, I could plug in a value for x and a value for y. So I could plug in this first point if I want. I could plug in 2 for my x, and I could plug in 3 for my y. Or lastly, my y-intercept occurs when x is 0. So if I'm going to look at what happens when x is 0, I can go backwards. That's a plus 2 to 0. It actually works. And then I go backwards again, and I have to subtract 4, so that gives me a negative 1. So I can go back up to that point, 0, negative 1. So I know my y-intercept, my b value, is negative 1. So therefore, y equals 2x minus 1. It gives me what my equation is in slope-intercept form. So that's how I can work with linears. Now, they're not always linear. They're oftentimes exponential, as what we're actually working on right now is exponentials. So that's our case for linears. Add. Every time you add on the left, add on the right consistently. That's the add property, which is linear. The next one we're going to look at is exponential. So here's my table. So I have the point 4, 100. I have the point 6, 70. And I have the point 8, 49. So if you look at what's happening on the left-hand side, what's consistently happening is I'm adding 2. Now I got to look at what's happening on the right-hand side. Now, you can also add a negative number. So if I take a look at that, I'd be adding a negative, possibly. So initially I'd be adding a negative 30, or subtracting 30 works as well. But that's not consistent. 100 minus 30 is 70, but 70 minus 30 is not 49. So it's not add. So the next thing that we're going to look at is add multiply. What do I multiply to 100 to get 70? Take the second, divide it by the first. That's multiplied by 7/10. So let's double check that again. Let's see if that works. 70 times 7/10 is 49. So this is add multiply. Add multiply means it is going to be exponential. So this is an add multiply case. So this is going to be exponential. So adding a constant to the value of x multiplies f of x by a possibly different constant. It could be the same. And just like add, it could be the same constant. So if I'm adding on the left-hand side, I'm adding on the right-hand side for linear. If I'm adding on the left-hand side, I'm multiplying the right-hand side. That's exponential. Now this happens when we have a list of numbers, so we can figure out what the equation is. So we're going to use a different example. Actually, I'm just going to do this example. And we're going to find the equation for it. Okay. So we've got 4, 100, 6, 70, 8, 49, x, f of x. Now, the generic equation we are going to use for exponentials is y equals a times b to the x. We should be able to take care of all different types of transformations that take place in here by just looking at this case. So we're going to look at finding our a value and finding our b value. Y equals a times b to the x. So in order to calculate this, I have to find two things. I have to find my a value and I have to find my b value. To begin with, the easiest thing to find is that y-intercept, because your y-intercept is when x equals 0. Because if I need my y-intercept and I put x equals 0, y equals a times b to the 0. What's b to the 0? 1. What's 1 times a? A. So a is just my y-intercept. That's your a value, because your y-intercept occurs when x is 0. Which means if I can go backwards in this table and come up with my 0 value, I will instantly know a. So sometimes this is super helpful. So when I do this, I go backwards, and I found 2, because here we said we were adding 2. So going backwards, I had to subtract 2, and subtract 2 again, so I get 0. So I have that 0 value, which is exactly what I need. Now I'm looking at my f of x values. My f of x values, we said we're multiplying by 7/10. You take the second divided by the first. So if I go backwards then, I'm going to have to multiply by the reciprocal. I'm going to have to multiply by 10/7. So in your calculator, take 100, multiply it by 10/7, and you get 142.857. Kind of ugly. Now keep that exact value in your calculator, go backwards one more time, and you get 204.082. Again, pretty ugly situations, so it's going to be pretty helpful for you to know how. So in your calculator, to go backwards, I took 100 and I divided it, which is multiplying by the reciprocal. And I got the 142. I know my calculator is kind of hard to see, but at least you can see the keystrokes I'm doing. 142.857. So now what I'm going to do is I'm going to do that again. Multiply that by the reciprocal. Make sure you put those fractions in parentheses when you have those, which gives me that exact 204.081. So now if you remember, we talked about this automatically gives you your a value. So when I'm writing equations, I have to have the exact value. So what I'm going to do now is I have to store that value. To store that value, I have to hit the STO button, which is right next to the 1, store, and then alpha, and then pick a letter that you want to put it under. I'm going to put this, because it's A, I'm going to put it under A. So I have alpha, and A is right above your math key. So I'm going to do that. Then hit enter. Now I have that exact 204.0816327, blah, blah, blah. Even whatever is not on the screen, you can't always see everything. I have all of that now stored in my calculator when I need it later. Okay, so now what I'm going to do is I'm going to write my equation with that in there. So y equals 204.082 times b to the x. So now I have to come up with what my b value is, and then I'll have my equation. In order to figure out b, I need to plug in a coordinate point. You pick the point you wish to plug in. It doesn't matter. My recommendation is pick a value that makes sense, makes it easy. I can't use the 0,204 because I already did that to find my a. So I'd probably be looking at either the 4,100 or the 670, whichever one you feel more comfortable with. So if I do the 4,100, 100 is your y, equals that 204.082 times b to the 4th. So now I'm going to take 100 and divide it by 204. So in my calculator, 100 divided by, I'll do second answer because that's the previous one, otherwise you can do alpha a, gives me 0.49, exactly 0.49. So 0.49 equals b to the 4th. Now we have to think about, okay, I need to get my b by itself. What's attached? An exponent. How do I undo an exponent? Take it to the reciprocal power. Okay, so now I have to take 0.49 to the 1/4. So bringing my calculator back up, that previous answer, 0.14 to the 1/4. Make sure fractions go in those parentheses. So therefore, my b value now is 0.8366. So b, I'm going to have to round, but my b value is about 0.837. Now, if I were going to use this equation for later on, I'm then going to take that value and I need to store it. So I'm going to take that, I'm going to hit my STO, alpha, and now that's the b value. So I'm going to put that under b, which is my apps key, and then hit enter. And now I have both my a and my b exact in my calculator, and that will lead us to when we do story problems, you are going to have those exact. So my equation for this is y equals 204.082 times b, which is 0.837, to the x. I cannot combine a and b. One has an exponent, the other one does not. So I can't combine things together that are not like. Okay, we're going to do one more example with an exponential equation because this one was nice. You could go back and find your zero value. You can't always. If I would have been adding 3 here and my first number was 4, I'd go back to 1 and then I'd go back to -2. So that's not going to work. So you have to make sure that if you can't go back to that 0, you have another tool that's going to help you get there. Okay, so in this table, we are going to look at the following points. First off, I'm telling you it's exponential. So I don't have to worry about, ooh, is it add, is it add, multiply. So in this table, I've got 2 coordinate points. So I've got 236 and I've got 554. So what am I adding on the left-hand side? Take the second, subtract the first. So that's 3. So if I went backwards, I'd get -1. Not going to help me. Now the next one is multiply. This one is not an integer. So take the second, divide it by the first, you get 1.5. So I'm adding on the left side, I'm multiplying on the right side. So now I need to write my equation. Y equals a times b to the x, where I need to find both my a value and my b value. So here's a quick little shortcut that works so that you can see how do you find both of those values if you can't go back and do your 0. So here's kind of the process that works. Please be conscientious of what you're putting where. So initially, I need to set up my equations. I have a y value and I have an x value. So I'm going to pick a coordinate point. I'm going to pick the one with the higher x value first. So I'm going to pick the 5 because 5 is bigger than the 2. So I'm starting out with that top equation. So 54 equals a times b to the 5th. And then I do my second equation, system of equations. 36 equals a times b squared. Now keep in mind this is exponential. Okay, now listen to this very, very carefully. 36 equals ab squared. 36 is the exact same thing as ab squared. They're equal to each other. The left-hand side has to equal the right-hand side. So since they're equal to each other, remember, if you think about how we do algebra, what we do to one side when we solve, we have to do to the other. So on the left-hand side here, I'm going to divide 54 by 36. I'm dividing those. But what I do to one side, I have to do to the other. Well, dividing ab to the 5th by 36 is not going to be very helpful. However, dividing ab to the 5th by ab squared is helpful. They're like, things are going to cancel out. Now, what I did to one side, I did to the other side. It's just a different notation. 36 equals ab squared. So if I divide one side by 36, I can divide the other side by ab squared. So when I do that, 54 divided by 36 is 1.5. A divided by a is, careful, 1. And 1 times anything is that anything. B to the 5th divided by b squared. Bases are the same. Subtract those exponents. So it's b cubed. Now, I need to find b. What's attached? An exponent. How do I get rid of an exponent? Reciprocal exponents. So take both sides to the 1/3. So in your calculator, take 1.5 to the 1/3, and I get 1.1447, etc. Not very nice. So b equals 1.145. Now that's b. I'm going to store that. STO. Alpha. We just found b. I'm going to put that under b. Hit enter. You just store right over the top of your values. So there's my b value. So now the equation that I have is y equals a times 1.145 to the x. So now I just need my a value. To find your a value, plug in one of the 2 points. It doesn't matter which one. Plug in 236 or plug in 554, whichever one seems easier for you. I like smaller numbers, so I'm going to do the first one. So 36 equals a times 1.145 squared. So I bring that value up, alpha b, and I need to square that, which is 1.31, etc., and then take 36 and divide it by that. Second answer brings back the previous answer. And I get 27.473 is A. It is crucial that you store your values when you start working with them later on. Otherwise, you're going to be wrong. Exponentials go wrong really quickly. If we round incorrectly to the thousandths place, we could be $1 million off. I don't know about you, but I don't want to be $1 million off when I'm working in money. So my equation for this is y equals, we just found that A, 27.473 times my B, which was 1.145, to the x. And that is my exponential equation for that case. So there are two different ways to find exponentials. One is setting them up with a system of equations above and below each other. The other one was finding your y-intercept, if you can, in your table, going back, finding your y-intercept in graph and finding your equation that way. Okay, one more type of problem. So based on these two tables, you should be able to determine whether or not they're exponential. So if they're exponential, remember, it's add, multiply. So take a moment and pause this for a second and figure out, are they add, multiply, are they add, or are they neither? So when I take a look at the left-hand side, so those are adding very nicely by 2. Okay, so those are adding by 2. Now, when I look at the f of x table, now I have to see, okay, am I multiplying by the same thing? I'm adding by the same thing. What's going on? So when I take my calculator, I need to look at how do I get from 72 to 200? So I take 200, just turn off this light for a minute so you can see. Oh, no, now you can't see. That won't work. So I take 200 and I divide it by 72 to see if it's going to be multiplied. So that's 2.77. So this is multiplying by 2.7, repeating it is. Now I look at how do I get from 200 to 392. So for that one, take 392 and divide it by 200. And you get 1.96. So are those the same? No. Now the last one is check to see if they're add, multiply. To get from 72 to 200, that's just over 100, and to get from 200 to 392 is 192. So nope, it's not add either. Therefore, this one is not exponential. So no. Right side, go through. Again, the left-hand side has the add. So here I'm adding 9. And then when I add 9 again, I don't get 30. But what I do get is I do get 21, so I'm going to add in that point. And then when I add 9 again, I get 30. So they skipped a value in between. That's okay. We're just trying to figure out if this function could be exponential. Okay, and skipping those values along the way, if I can fill them in and still follow that pattern, I'm good. Now I look at the right-hand side. Am I multiplying? So take the second divided by the first. So 121 divided by 1.1 is times 1.1. Okay, so now if I multiply 1.21 by 1.1, I do not get 1.4641. Instead, if I multiply by 1.1, I end up with 1.331. And then if I multiply by 1.1 again, I get 1.4641. So I was actually missing that coordinate point. So as I go from one point to the next, if I'm missing a physical coordinate point, yes, it can still be exponential. You just have to make sure that you have that point in there, that it mathematically falls into place. So add, y equals mx plus b. That's our add property. And then y equals ab to the x is add multiply property. So whatever kind of list of values you get, you should be able to determine what the equation is based off of it. Or as I'd given you in the second to last problem, I gave you 2 coordinate points and I said it was exponential, and you can find your equation. That's what you're going to be doing in your story problems in the next one.